Hi, my name is James Kathilangal. I'm a senior application scientist here at LI-COR. Today I'm going to talk about the LI-710 Evapotranspiration Sensor. The LI-710 measures vertical wind and water vapor concentration in the air and uses the principles of eddy covariance to estimate evapotranspiration. So we have a pair of transducers here which measures the vertical wind, and we have an intake tube here where the air is sampled in, and we measure the water vapor concentration in here. In terms of installation, we will want to set up the system in a similar way as we will do for an eddy covariance system. So we want to put it above the canopy at twice or 1.5 times the canopy height, depending upon the height of the canopy, and then we will power it with a 12-volt supply. The LI-710 is an SDI12 sensor. So to show the connections, I have here an USB to SDI12 adapter. This is made by the manufacturer Vegetronics, and I'm going to connect the sensor to this adapter, and then we can see how we can get the data or control the sensor using a terminal program on my laptop. The wires, we have three different colors here. There's a blue, which is the data or the bus, the black, which is the ground, and the brown, which is the power wire. To wire the sensor, I will have the blue wire, which is the data or the bus, go to the bus marked on the adapter. And then the black wire, I'll go to the ground on the adapter also. I will have to connect the grounding of the black wire or the negative wire to the negative of my power supply, which I have here, so that we can have a ground on the bus adapter also. So I'll use a jumper cable to do that. So I'll connect that jumper cable to the power supply negative here, and then I will connect both of those wires to the SDI12 adapter ground plug. Now I have the brown wire, which is the power wire, which I can take it to the positive of the power supply here. When the sensor is powered up, you should be able to hear the pump in the sensor going, and also the sonic transducers firing. To configure the LI-710 sensor, here I'm using the TerraTerm software. It's a terminal emulator. I can connect to the USB to SDI12 adapter via the TerraTerm, and then I can send commands through it. Before I do that, I have to make sure that I set up the terminal in the right way. When I send the command, I need to make sure that I send it with a carriage return. So I enable the setting just to send a carriage return with the commands. And then I want to make sure that I make the connection with the right serial port. Choose the serial port which I have the adapter attached to at the baud rate of 9600. By default, the 710 sensor has an SDI12 address of 0. So when you send any command to the sensor, you need to use that address also with the commands. And with this SDI12 adapter, I have to send commands in a mode called a transparent mode. So every command has to start with a T. So to identify the sensor, I will send the command T space 0 for the address, I for the identification, and then the exclamation which concludes that command. And the sensor should respond with the manufacturer name, the model, the serial number, what firmware it has. All that information is in the output of that I command. Now if I have to change the sensor's address from 0 to 1, I can use the A command. Again, I will start with a T and then I will start with the address I have, which is the original 0, and then use the A command and send the new address which I have to change it to. In my case it's 1 followed by the exclamation sign. Enter, and I get an OK. So now if I want to confirm that the sensor is there, I will use the T followed by the 1 and then the I command to identify in the new STI12 address of 1 followed by the exclamation here. So I get a response back. So now I have changed the address of the sensor. To make the measurements, there are different ways I can do it. I can use an M command, or I can trigger the sensor with an XT command. An XT command essentially is an extended command where I can trigger the sensor to start a measurement, or at the same time it is stopping the previous measurement. So if I want to start a measurement, I can use an XT command, or I can use an M command. The M command basically just gives you the fluxes from the previous half an hour. If I have to time my measurement to a particular time, I have to always use the XT command so that I can trigger the sensor at a particular time and repeat the process again and again. To send an XT command, I can again start with a T space, the address which now is 1, XT followed by the exclamation, and the sensor would say ready, which means it's triggered and it's starting a measurement sequence now. To make a measurement, I can again do the T, next is the address which is the 1, and then the M. So the M command, I can be an M0, M1, M2, M3. They all give you different outputs, which are all explained in the manual. So for M0, I will do the 0 and then followed by the exclamation. Sensor should respond with 100119, which tells me that it has 9 outputs, and then it's going to take 11 seconds to process that information and give you that fluxes. So typically in most loggers, you just send the M command and the sensor, the logger itself will follow with the rest of the commands to get you the right output. In this sensor, in this adapter I have, when I send the M command, I have to follow through with the D commands to get the different outputs. So if I send the M command, in this case I'm going to send an M1 command, I get back the address, the 11 seconds I have to wait till I get the outputs, and 9 is the number of variables. So I get 9 variables out from it. So to get the 9 variables, I have to still send a series of D commands. So starting with the D0, so I have the T, the 1 for the address, and the D and 0, and followed the exclamation. That will give me the first 3 outputs, which are for that particular M command. I get, I have 9 outputs, so I get the first 3 here now, and then I have to follow through with the D1 command, which again here I have to do the T, the address, the D1 followed by the exclamation, and I get the next 3. Then the next step is, because now I get 6 variables, I need to get 9 variables, so I need to send one more command, which is the D2 command. So again I will do the T space address D2 exclamation, enter. So again here in this adapter you have to send all these commands manually. Different loggers do it in different ways, but if I have to use this adapter to get data from the sensor, I need to program all these steps in some kind of script to get all this data in a periodic manner. This concludes the presentation on the LI-710 Evapotranspiration Sensor. If you have more questions, you can always refer to our website, or you can contact us directly. Thank you.